Macros are elements of programming language that enable the replacement of one, usually shorter text with another. In different assemblers, for example NASM and FASM, the syntax can differ, but the idea remains the same. In this video we present the MASM implementation. There are few types of macros in MASM: text macros, macro procedures, repeat blocks, macro functions, predefined macro functions, and string directives. Text macros are a simple replacement of one text with another. They are defined with the directive text-eq, which creates a new symbolic name and assigns the text to it. The text assigned should be closed in angle brackets. It can be a previously defined macro or can be a text representation of an expression. Using text macros, it is possible to name some constants, like pi, shorten other directives, and even create your own instruction names. Previously defined text macro can be redefined later in a program, like the message symbol in the example. In the case of expression, the percent operator calculates the result of an expression and converts it into a text representation. This process is named expansion, and the percent operator is the expansion operator. In the example, the first macro assigns the 3 plus 9, the second macro calculates the expression, converts it into the text representation, and assigns the text 12 to the symbol. Macro procedure is a definition of a fragment of code that can be used later in the resulting program. In some assemblers, they are named multi-line macros. The use of the name of a macro procedure later in the source program causes the so-called expansion of the macro. It is worth noting that for every usage of the macro, the assembler will place in the resulting program all elements specified in the statements inside the macro. Macro procedure can have parameters. They are treated as macros themselves, so the use of the parameter name inside the macro results in the replacement of it with the actual value. The simplest definition of a macro procedure contains the name, macro keyword, a list of statements inside the macro, and m at the end. Here is an example of a simple macro which makes a copy of data from the source to the destination. It takes two arguments, arg1 and arg2. The arguments of the macro must fit the instructions used inside it. They can be previously defined variables. The first argument can be a constant, or you can even pass the names of other registers. If the actual parameter is empty, it may result in an error in the expanded line, because empty parameters are assumed to be empty text. In the example, the second line of the expanded macro is invalid and will signal an assembly error. There are two ways of avoiding errors in macro expansion. We can mark the argument as required or assign the default value to it. In the first case, the error will be signaled, but in the line where it really exists, not in expanded line. It helps to locate the error. When we set the default value of an argument, this value will be assumed in the expanded macro in case the actual argument is not present. If a label needs to be defined inside the macro, it must be declared as local to avoid ambiguity. In general, any symbol can be declared as local. In such a case, it will only be visible inside the macro. The local directive can be used for this purpose. It must appear in the line next to the macro statement. The macro can return a value. Such a macro is called a macro function. As all macros are texts, macro function always return text. Returning the value is possible with the use of exit_m directive. The argument of the exit_m must be text or the result of another macro function. Numeric values must be converted to text form with the expansion operator %. Other forms of macros are repeat blocks. They are automatically repeated. The number of repetitions depends on the condition or is determined by the constant value or the list of argument values. There are repeat, while, for, and for-c repeat blocks in MASM. We will show examples of those constructions which perform the same functionality, define 5 bytes of values from 1 to 5. The repeat block is expanded the number of times specified in the constant expression. The while block is expanded as long as the condition is true. The condition can be any expression that evaluates to 0, assumed as false, or non-zero, being true. The for block is expanded for each argument in a list. The parameter is a placeholder that represents the name of each argument taken from a comma-separated list. The for-c is similar to for, but takes a string of text rather than a list of arguments. The text must be enclosed in angle brackets. Statements inside the block are assembled once for each character from a string. The last type of macros are predefined macro functions. MASM offers a set of predefined macro functions usually used to process texts. We can cut a part of a string, find a substring, concatenate strings into one, and count the number of characters in a string. Certainly, they operate at assembly time, not at runtime.